Question number 19. The resistance of the component X decreases when the intensity of the light increases. Okay, first let us do one thing. Let us label the parts. Okay, it may take some time. Let us do it first. Let me call this potential difference, that is the EMF of the battery, as E, and this as X. Instead of X, I will call this as Rx, and this I will call this as RO here. Okay, now let us read the question. So when light is incident onto it, it's something like an LDR, then the resistance decreases. That's what it says, right? Resistance decreases. When resistance decreases, when intensity of light falls onto it. Intensity falls onto it. Intensity of light falls. You can just say light falls. Okay. Then X is connected in series. Okay, all blah blah blah. Okay, ammeter and voltmeter ideal. Okay, ammeter and voltmeter ideal. What does it mean? It means this has a resistance equal to infinity. No current will pass through it. Okay, I is equal to 0 here. All the current extracted from the battery will only pass through this one here. Okay, and pass through the ammeter. The ammeter also will not have any resistance. Okay, so therefore it's an ideal ammeter. What is the change in reading of the ammeter and the change in reading of the voltmeter when the light incident on X is increase? When intensity increases, what will happen? The resistance Rx will still reduce, right? Will still reduce. Now what we will do is, let us arrive at an expression here. Now what do we have here? We know that the total current I is equal to total EMF divided by Rx plus R. What did I do? I just apply Ohm's law over here. Okay. So therefore, now what do I need? I need the current here. Now what is happening over here? When intensity falls, then what can happen? This Rx will reduce. When Rx reduces, denominator reduces, what will happen to the current? Current will rise here, right? The ammeter will detect a higher value of the current. So therefore, these two are incorrect. Okay, so these two 50%. Then the next one. Now what is the voltmeter reading? Now what we do is voltmeter. What is the voltmeter here? Voltmeter here measures I times Rx. I times Rx, right? So let us look at this expression here. So I will now simplify this. I will write I times Rx plus I times R is equal to E. I have cross multiplied here like this. So I can write I Rx is equal to E minus IR, right? So I want to find out this I times Rx, which is Vx. Vx, the voltmeter reading, is equal to E minus IR. Now what's happening over here? This R is unchanged, right? This R is, I am not changing this value of R. Only the value of I is increased. When the value of I is increased, this IR will increase. I will just give you some numerical value. Okay, let us say for example, initially the value of E is unchanged. It's 10 volt over here, and the value of R, let us say it is equal to 1 ohm. And the current was seen to be, let us say for example, 2 amperes initially. Okay, when some amount of light was been falling onto this one. Okay, now when more light intensity is falling, what can happen? The current will increase. Okay, now what initially what was the Vx over here? Vx in that case, in the earlier case, was 10 minus 2, which was equal to 8 volt. Okay, now if more intensity of light is falling, then what can happen? The Vx dash will now become 10 minus, this current would have been increased. When the current, let me say there is an increase in current, which is 3 amperes. From 2 it has become 3. Okay, but the resistance does not increase, which is 1 itself. So this will become 10 minus 3, which is 7 volt here. What has happened now? The voltage across the Rx element has decreased, right? So therefore, which is the right option? Ammeter reading increases, voltmeter reading decreases. So option A is the right option. Okay, let us move on to the next one.